Good morning to all. Myself Shazira, and today we are going to continue on our topic of science, which was measurements and motion. So in my previous video of this topic, we had learned about why this standardization of unit is very important. And also we had learned about the sum of the standard unit and some conversion tables also. And we had understand the meter, the kilometer, the centimeter and so on. So now today in this video we are going to move on to the standard unit. And I think we had talked about the SI unit also. What is the SI unit? The international standard units. Now international system of units. International system of units. Now we are going to learn about some of the SI units today. So let's start. Firstly, let's talk about the temperature. The SI unit of temperature, the SI unit of length, then the mass, and then let's say capacity, so what are the standard unit? What are the SI unit? Sorry, I'm talking about the standard SI unit of these. I think you know about the SI unit of the temperature, Kelvin. It is Kelvin. And then the SI unit of length, I think you know, the meter. And then the SI unit of mass, yes, the kilogram. And then we have the capacity, which is the liter. And I want to talk you about two more things. The luminous intensity. How to measure the luminous intensity. But first, what is this luminous intensity? This is just how much the bright object is. How much luminous it is. As we had seen some dim bulbs and some very bright bulbs. So the luminous intensity, highlight my word, luminous intensity. In the simple word, how much is that object luminous? How much is that object bright? So for measuring a luminous intensity, there is one SI unit, I think you know about that, candela. I think this candela is similar to the candle. Now let's move on to one more SI unit, which is ampere. And this is the SI unit of current. So we had mentioned some SI unit of the temperature, length, mass, capacity, luminous intensity and current. What are they? They are the SI unit of temperature is Kelvin, then the SI unit of length is meter, then the SI unit of mass is kilogram, then the capacity is liter, then the luminous intensity is candela and the current is ampere. Do you know one more thing about this? Ampere. Do you know the five plug in which we plug our phone, our chargers to charge our phone? That carries 5 ampere. And do you know about the 3 plug? That carries 15 ampere, and that is used to power up the TVs, and also the computers and the geysers and so on. So I think this is clear to you, the SI unit. And now we are going to learn about one more thing. Do you know that how can we say, if we have no scale, how can we define that this much is a meter or a centimeter or anything? Let's take an example for that. So can we define that with a rod? As we had taken this example in our previous video, we had taken that one rod. Let's say that is 1 meter. So why we can't take that rod as the definition that this much is a meter without the scale? Now that's because a rod is a real object. It is not an imaginary rod. So that is a real object, and that rod is basically the metal. It is basically the metal. And as you know that metal increase in their length when we heat them. And when we cool them, they decrease their length a little. So if this will happen, that how can we at an accurate position that this much is a meter? It start increasing, it start decreasing, and that should be not. We know that the measurement, the conversion table between the currencies, the Indian currency is the rupees, the USA currency is dollar. So the conversion table between these two increase or decrease a little by the time, but the measurements, the conversion table of the measurements always are the same. It doesn't increase or decrease. So how can we take a rod to define a meter? So how can we define a meter? Basically, meter is said to be one out of a very big number of seconds. The light traveling, the light travels, and that the light traveled in one upon a very large number of seconds. So the meter is defined like this. The distance traveled by the light in 1 divided by this much, this second. So I think it is clear to you why we can't use a rod for defining a meter, that this is this much. Now let's see one more thing. Do you know the right spelling of the meter? I think you know that, METRE. Very simple. And I had also written this over here. But if you are going to go in a USA, in a simple word, America, what you are going to see? If you will ask someone in the America, what is the spelling of this of the meter? So do you know what they are going to tell you? They will tell you that METER is the spelling of the meter. So there is one very weird and funny thing in the whole world, or in the English, the official English, which is just the UK. In that, what happens? The spelling of meter is METRE, and in the USA it is METER. A very funny thing. And do you know about one more example? Let's take aeroplane. So, do you know the aeroplane? Let me write down these funny things. So, in the UK and in the USA, in the UK the meter the spelling of meter is METRE, and also in the rest of the world, but in the USA the spelling of the meter is METER. Then in the UK the spelling of aeroplane, I think you know that we have learned that aeroplane. Very simple. AEROPLANE. But in the USA it is airplane. Let me write down that. Airplane. A very funny thing. AIRPLANE. So these are the two examples, some examples of the different spelling, of the difference between the spellings in the rest of the world and in the USA, the America. Very funny thing. Meter, but the spellings are different. And the airplane. Now I think this is clear to you. Now let's move on. And now let's take something that we are going to talk about, basically the errors and errors. Now let's see. So if I want to measure a line, listen, if I want to measure this line, and if I will take a scale, let me take that out over here. So if I will take a scale like this over here, sorry for the delay, and now you can see I have a scale over here, and if I want to measure this line, how I'm going to measure that? Very simple. I will put my scale like this. Now this is not a straight line. Let me draw one straight line with the help of this scale. Now if I want to measure this line with the help of a scale, how I am going to measure? Like this. But what will happen if I measure like this? A very funny thing. Like this, like this. So sometimes, really sometimes, this thing happens, and because of that we get some errors in the measurements, and we get a wrong length. So we are going to learn about 3 errors which we can make in the measurements. Let's see what are they. So first we are looked about that. Perfect alignment of the scale. If the alignment of the scale is not right, it is something like this, or it is something like this. If it is like this, accurate, in a straight line, then we will get a right measure. But if it is like this, so we will get wrong in our measurements. Now, what could be another mistake which we could make? Let's see about that. So, do you know that if I will take a scale, and you know that this scale is a real object, right? We can't have a scale with our hands. So this one, or it is not in our mind. We can't have a scale in our mind. So this is basically a real object, and this could damage, right? It could damage, like someone broke this, and especially these plastic ones. So this could, I think you understand, this could be damaged, as this is a real object. So sometimes what happens, usually the ends of the scale broke, and because of that we have something like this. Let's say this is basically 15 centimeter long scale, and let's imagine that the 3 centimeters of the scale from the starting is broken down. now I have this much scale. Can I measure with this scale? If the line is going to be shorter than this length, so I can measure. And if it is bigger, so I can measure like this. Let's say from this 6 centimeter to this 10 centimeter as 4 centimeter, and then we can measure that 4 centimeter, and so on, so on. So now let's imagine that from the 3 centimeters of the scale from the starting is just broken down, and we have this much scale. How can we measure? Let's see. So if I will have a line like this, and if I will measure by the simple and a new scale, a perfect scale, what I'm going to get? I will place this, I will check the alignment, and I'm going to see that it is 15 centimeters long. But if my edges, if my ends of the scale is broken like this, so how can I measure? If I will measure that, I will see that here it is 15 centimeters, and then it is 7 centimeters. Okay, so 15 plus 7, what we get? We get 22. So 22 centimeters long. Is it a right measurement? Is it a right length of this line? No. So this error is known as the zero error. When the ends of the scale is broken or damaged. Now, so how can we avoid this error? How can we prevent this error? Let's say our scale is broken. Now how can you measure the length? For that, we have a simple thing. What you have to just do, let's say 3 centimeters is broken, and we are going to measure from the 4. And what we had got, let's say it is a smaller length, let's say this one. And how we will measure this? Very simply, I will put like this, and then we had got 10.5. So is it the length of this line is 10.5 centimeter? No, but what you have to do, you have to just subtract the ending point from the starting point from the ending point, the starting centimeter from the ending centimeter. What does it means? Let's see. So if I have a length, if I have a length like this, and I had started measuring this from the let's say 4 centimeter, and I had ended at 10 centimeter. So what you have to do, you have to just subtract this 4 from the 10, which is basically 10 minus 4. What you are going to get? 6. 6 centimeters, and that is the accurate length of that line. So that's how you can win upon the zero error. That's how you can measure the length when the ends of the scale is broken or damaged. So very simple. Subtract the length, the starting centimeter from the ending centimeter, and then you will get the length and the number, which is nothing but the length of that line which you are going to measure, which you are measuring. So very simple. Now let's see one more error, the last error. And then let's say we have an object. Let's say here is my marker, so let's measure this one. If I am going to measure this marker, sometimes what happens when an object is little thick, sometimes an error can occur. Do you know? Very simple error it is. Okay, let me explain you why does this thickness matter. I think you are wondering about that. Why is this thickness matter? So for that, let's take something like I have a paper over here, this one, and if I want to measure, I can simply do like this. Take my paper like this and then measure it like this. So here is no problem, but here we can just simply, if I am going to see from here or from here or from here, I can see a same length. But what if I have a thick object? Let's say we are taking a marker, and if I want to measure this, what happens? It is thick. It is thick, and because of that, and now let me align this. So because of that, when we see from the upper side, like if I will see from here, what I am going to get? I see that it is 14 centimeters long. But what is the accurate one? Is it 14 centimeters long? No. It is 13 point. Let me see that. It is 13.6. So, from here I can see that it is 14 centimeters long. From here I can see that it is 13 centimeters long. What a error it is. And this error is known as the parallax error. Parallax error. And for avoiding this error, what you can do, you have to simply see from the straight upper side, from just above of the side. Let's say I have a scale like this and I have an object like this. Now, if our eyes is going to be at the upper, just exactly above, like this, we are going to get the right measure. If you know that the light travels in a straight line, so when we are going to see from here, what we are going to see? If the light travels in a straight line, and if the object is transparent, we can see this one. If the object is transparent, so the length could be wrong. Or if it is a little away like this, so we can also get the right measure, the wrong measure. Because it could be a 1 millimeter wrong. So that is the parallax error. Very interesting error it is. So we had learned some errors, and we had learned how to correct these errors. So how to prevent this parallax error? Just see from the just exactly above that object, and you are going to get the right length of that object, the accurate length of that object. So very simple. Now let me list down all the errors which we had learned. We had learned that if we had learned about the zero error first, then we had learned about the parallax error, and before the zero error we had also learned about that not the perfect alignment of the scale. Perfect alignment of scale. Not a perfect alignment of scale. So these are the some errors So we had also talked about the corrections also. Now let's end our video over here, and in my next video of this topic we are going to end in that video, and we are going to learn about the motion and its type. So for now, let's end over here, and thank you for watching this video. And if you want any improvement in me, so you can just comment it in the comment box. Thank you and have a nice day ahead. Thank you.